As we're working with calculus, we might run into something that's called a composite function. So I just want to make sure that we're comfortable with composite functions. At the end of this lesson, you'll be able to evaluate composite functions. First of all, what is a composite function before we start evaluating them? A composite function is generally one function happens before the other function. Let's do an example. One of my favorite activities to do is to go shopping. And when you are shopping, you run into composite functions all the time. Let's say I went to a store and I'm always looking to get the biggest bargain and how can I get the most for my money. So let's say I go to a store and they have kind of two sales going on. They've got the, let's say they have a 20% off sale. And then the other thing that they have going on, let's say they've got a 20% off sale going on. And then they've also got, you get $10 off, so pretty good deal, I guess. They need to decide that you can't do them both at the same time, so they either need to take the 20% off first and then take $10 off the price, or they're going to take $10 off the price and then take 20% off of that. So as a consumer, there's a better way, and as a retailer, there's a better way. As a retail, of course, they're going to take the $10 off first and then take 20% off of that price because they're not taking then 20% of as big of a number. As a retailer, of course, I would like them to go the other way. But that's just as talking about a composite function. One happens before you do the other function. So we're going to get into some examples where we're dealing with real function or mathematical functions. Let's say I'm given f of x equals the square root of x and g of x equals x squared minus 1. The first thing that we're going to try to evaluate is f of g of -4, and that's how I would pronounce that. The first thing that we're going to do is we're going to deal with the function inside first. So the first thing that we're going to do is evaluate g of -4, which means I'm going to go into the g function. Wherever I see an x, I'm going to put -4. So -4 squared minus 1, that will give me 16 minus 1, which would be 15. So basically what I'm going to do now, I've just found that g of -4 is equal to 15. So now I can plug that in for there. Now I'm going to evaluate the f function at 15. So now I'm going to go into my f function and plug 15 in for my x, and that's as simplified as it can get. So that's what f of g of -4 would equal. Going over here, we have g of f of x. This time we get to evaluate f first. And notice this time they don't give me an x value to evaluate it for. So we're actually going to put f of x right in there in our parentheses. So we'll put f of x is equal to the square root of x. So now what we're going to do is go into our g function. Wherever we see an x, we are going to put the square root of x. So we are going to put the square root of, whoops, start that one over again, sorry about that. All right, so square root of x squared minus 1. If I take the square root and square it, the square and the square root just cancel each other out, so I'm just going to be left with x and then minus 1. So that's what g of x, f of x would look like. Just one other quick note. If I have f and then there's a little circle, g, looks like fog, but this is also just another way of writing the composite function, and all that means is f of g of x. So it just means that same thing, so don't get yourself confused when you see that. So hopefully now you can evaluate a composite function.